equals 1 is given by FQ equals E. The frequency of light, E equals HF, has previously been explained theoretically by the simple observation that the frequency is determined quite directly from the number of quintessences, NQ, within the photon. The same principle has also been shown to apply to matter. 0216. Let us now follow these equations for matter by calculating the wavelength of a photon from the gravitational constant as an example, and also as a test of these observations and to demonstrate that the gravitational equations can also apply to the quantum world. 0217. If NQ equals ECV3RQ2, 39A. 0218, where R is the general relativistic increase in radius, and RQ is the radius of quintessence, EQ. 33. Where F equals E, H equals NQ, substituting for NQ, then the frequency of the photon Fy, where 3 equals 1, is given by FQ equals EC, 3RQ2, 0219. Using the standard equation, R equals GM, 3C2, EQ, 34, we may substitute for R, thus we have F equals GMI9RQ2C15 thus Fy equals 9R2C3MYC2 and as E equals MC2. Ge, 40, Fy9R, IC3. Indeed, as 9RQ2 equals GHC3, then 1 equals ELH equals NQ. 0220, it is possible to also demonstrate that the same relationship holds for the wave equation for matter. If we take the relativistic wave energy of matter, which has been previously derived, 0221, this includes the term for the number of quintessences flowing through the electron in the complex vectors of space-time, to give the relativistic electron momentum, p, and a term for the rest mass, thus substituting into 40. Ge, 40. Fy equals 99c. 0222, as F equals 132 NQ for matter, then the equation expands to G equals I32 east as A equals B, F then 9R2C3B, 41, A, Q, G132E, US 2006 00739760 Al. 0223, then the equation again reduces to 9R2CA, 3, G equals Q, ASE. 0224, equations 3, 40 and 41 are important as they show 14, 9R2C4, equals Q indeed as 9R2 equals GHC3, then E equals HC Shea, April 6, 2006, 3A, 2. That the quantum wavelength of any particle of rest mass m can be derived from the gravitational constant g, thus linking quantum mechanics to quantum gravity. 0225, it is therefore important to confirm the numerical accuracy of the above equation, 40. We can do this by comparing the result of the standard computation of the de Broglie equation, in a range where de Broglie itself is likely to be most accurate, which according to these observations is in the low energy range, see section on wave-particle duality. 0226, if we take an electron with an energy of 0.1 keV, the wavelength is conventionally given, where the kinetic energy of the electron E is given by the product of the charge of the electron, C, and the potential applied EV equals 0.1 key, by the standard equation. E equals H1P equals HL, egg 2 meters 0, 112 thus. 0230, equation 2 is the very same as the universal wave equation derived from first principles for the wavelength of Titan matter, which allowed a relativistic solution to the equations for wave-particle duality, see wave-particle dual ITY. This now indicates that these quintessential equations are compatible with relativity, quantum mechanics and quantum gravity. O231, Graviton structure. O232, from these observations, if the value for the gravitational constant is substituted into the equation, 35, we may now estimate the probable geometric structure of the gravitation, which is the force particle mediating gravity by acting on quintessence. Thus the gravitational constant has been previously derived from the vibration of quintessence by the equation G, hit C, equals 9, TRQ2, MQ, 36. O233, this is in accurate agreement with the value for G, 6.67x10 nm2 kg2. This suggests that the most probable mathematical representation of the graviton, 0, the equals 6.63x10 to 34, 1.602x10 minus 1 degree by 1x 102 by 18.22x10 31 hence. AL 1.23x10 minus 1 degree m using 9R2C4 equals where E equals YMAC2, E 1/2, 3A. Third force carrying particle is 1 equals it C 42. O234, thus the gravitational constant G can be given by the mass and radius of quintessence and the structure of the graviton. G equals 9 ITRQ2 align Q 43. Closing parenthesis. O227, 2 at 0.1 key, electron velocity is 6x 106 sec, thus 13 equals 2x10 and y equals 1, 1v2, c2, 1/2 equals 1.0002. Thus, 9 by 1.82x10 minus 2 degrees by 80.78x10 32y. O235, this shows the gravitational force to be related to the fundamental radius of quintessence spacetime, and the graviton. O236, quantized general relativity. O237, the classical general relativistic formula, as given. 6.76x10 to 11x 3x 1.0002 by 9.11x10 to 31 by 8.998 by 101 degrees. By Einstein is equals 1.21x10 minus 1 degree m. O238, where r is effectively the curvature of space-time. O228, divergence between the de Broglie equation and the above equation, 2, occurs at intermediate and high energies where it is generally accepted that the standard de Broglie equation may be less accurate. The values for EQ, 2 and de Broglie are compared to recent experiments which demonstrate a relativistic curvilinear plot for wavelengths of matter in keeping with EQ. 40. O229, the de Broglie equation in the non-relativistic format yields a simple log, linear scale, which is not in keeping with relativity, whereas EQ, 3 is dependent on relativity and mathematically accounts for both relativity in calculating the wavelength. Indeed, recent experiment on quantum tunneling through a wire mesh strongly suggests that the relationship between energy and wavelength is relativistically curvilinear, ARF1. Furthermore, equation 3a suggests a fundamental relationship between energy, E, relative velocity, Vic equals 3, gravity, G, and the quantum wavelength, X. Denotes the contracted Riemann tensor of curvature and is the energy tensor of matter. O239, if we substitute the energy tensor matrix of the electron, EQ, 9, x time, for the energy tensor of matter minus 1, and the metric tensor of the space-time lattice x time for the contracted Riemann tensor, we can arrive at the same solute ions for general relativity. O240, furthermore, in his published paper on general relativity, Einstein defined the constant K as IC equals 8ITG, C2, O241, therefore Einstein's equation should be written as 87Rg, 43, R, minus 112 grams, R equals T. US 2006, 00739796 Al 15. 0242, Einstein himself was apparently not happy about the right-hand component of the equation. However, we find that this part of the equation can now be explained and quantized by substituting the gravitational constant, G equals 97 CRQ24MQ, EQ, 42A. 0243, giving 87, 29R2, 44, 1, wing C2, 0244, by substituting MQC2 equals H, and further substituting H equals H27C, we arrive at a quantized solution to Einstein's equations, where AQ is the surface area of quintessence, AQ equals 47 CRQ2, 1, is the graviton, P equals 0 C, and H is Planck's constant, thus 9A, 45, RW minus 112 grams, R equals trademark. 0245, the gravitational equation can now be further understood on a logical basis. The term AQ equals 4nRQ2, where represents standard term for the surface area of a sphere of quintessence for the 9 space dimensions of the space-time lattice. H is the energy content of quintessence 6 diamond 1, is the graviton, thus the right-hand term now represents a true, metric energy tensor, of matter. 0246, this leads directly to the standard solution to the Iffeld equations for the general relativistic increase in radius r of an object, where A is the surface area of a sphere of a given mass m, such that r equals b 4/43 t, r equals gm 3c2 34. 0247. Furthermore, although equation 45 gives the same solutions as Einstein's equation, which is essentially correct, the difference is that the equation is now dependent upon Planck's constant, h, and moreover the radius of quintessence, which now defines a quantized solution to the equitions. 0248. Graviton force characteristics. 0249. Similar to the photon, the previously derived equation, 42, for the graviton, P equals 0 rig, appears to also mathematically represent a helical ringlet of quintessence but with a spin of 2. For the photon, taking the direction of motion as the x-vector and its axis of spin also as the x-vector, would account for the electromagnetic force and its attraction and repulsion characteristics. In the case of the gluon component, 7, C1/2, if the direction vector is x, then the axis of spin would be in the y vector, the same as quasi-electrons, accounting for the particle binding characteristics of the gluon force. In the case of the graviton, if the direction of motion was in the x-vector, the graviton spin axis would be in the z-vector thus, as will be demonstrated, accounting for the gravitational force. 0250, the spin axis of the graviton can also be derived using the known characteristics of the electron. If an electron is traveling in the x direction, then its spin axis is determined by the sign of the jy vector, up or down. This, April 6, 2006, view is in agreement with conventional theory, which indicates that the electron spin is similar to a rotating planet orbiting the Sun. The electron even appears to have orbital precession. As the electron passes through the space-time lattice, this spin would generate the formation of gravitons. This would occur as a result of the ejection of the excess quintessence passing through the electron. As the electron spins, the ejection of these gravitons would occur at a tangent to the electron's direction of motion. The ejection of the gravitons would occur, similarly to the ejection of energy of a pulsar or quasar, through the equivalent of the north and south poles of the electron, thus propelling the graviton in the direction of the electron's y vector. The ejection of the graviton would reorientate and impart a specific angular momentum to the gravitons, which would thus end up spinning on its own z-axis. If, for instance, the graviton is released from an upspin electron, the graviton will be rotating clockwise and its leading edge will displace quintessence downwards. In turn, this will provide an upwards force. 0251. This picture accounts for Fleming's left-hand rule, is logical and provides an explanation for the magnetic force around a wire. According to the left-hand rule, if the direction of the current is in the x-vector, the magnetic field is in the z-vector, and the force is upwards, in the y-vector, in accordance with the above model. Therefore, this particular spin axis and the structure of the graviton results in its force characteristics. As the graviton is very small compared to the electron and both have different rather rapid spin axes, it is difficult for these to bind and interact. Nevertheless, because the graviton has a spin of 2, and as its spin axis is perpendicular to its direction of motion, in the z-vector, it readily displaces space-time quintessence to produce grav-ity. Thus, because the graviton is able to displace space-time, it is capable of escaping a black hole. How else could the effects of gravity be felt beyond a black hole? 0252, Quantum Gravity and Electromagnetism. 0253, with the above electron model of graviton production, the nature of magnetism can be understood from first principles. Furthermore, the presence of a space-time lattice links relativity, and the forces of gravity with the electromagnetic and other forces of nature. Indeed, evidence for these links may first date back to the 1820s, when André Ampère first defined the amp. The force of attraction between two parallel wires 1 meter apart, each carrying 1 amp in a vacuum, was defined as none other than the permeability of free space 2x 10 to 7 n per meter of conductor. Thus, conventionally, the magnetic field strength around a long straight wire is given as B equals PO1, 23 tr. 0254, where I is the current and No is the permeability of free space, 4nx 10 to 7na2. 0255, the attraction between two wires both carrying negative charge is, however, counterintuitive, as negative charges should repel. A conventional explanation overcomes this by invoking the presence of a magnetic field which is created by the current by the production of virtual photons. Thus we appear to have an explanation for the effects of magnetism which involves virtual photons. However, these photons are not observed. More accurately, according to conventional special relativity, the magnetic field is none other than the electric field viewed relativistically. US 2006 007397 Al16. 0256, a more satisfactory explanation, therefore, lies in the interaction between the electrons and the space-time lattice. The moving electrons in the two wires interact with the lattice to produce gravitons, which are in phase when both streams of electrons are traveling in the same direction. The gravitonic waves interact constructively to disperse the space-time lattice between the wires and induce an attractive force between the two wires, which produces in effect the permeability of free space. Thus this force results from the vibration of quintessence itself. 0257, conversely, in two wires with current going in opposite directions, the graviton waves are in antiphase and would interact destructively between the wires. The gravitonic waves traveling radially outward from the wires would, however, disperse the lattice outside the two wires and produce apparent repulsion between the wires, which is exactly what is observed. These effects of electricity suggest that gravitons act as waves and that phase is important. 0258. This effect is also seen with the north and south poles of ferromagnets. Nevertheless, with matter other than iron, cobalt or nickel, the graviton emission cannot be phased as the atoms are unable to align and magnets do not appear to exist with other materials. 0259. In ordinary magnetic system, the release of gravitons from the north pole would be exactly balanced by those released from the south pole of the magnet, and hence there would be no net force on the magnet until an external magnet or electrical current were applied. 0260. Overall, the magnitude of the forces in electrical systems where electrical conduction occurs are well defined by the permeability and permittivity of free space n0 and 0 euros, where v is the constant velocity of the charge and euro is the electric field produced by the charge. V equals UOCO VE. 0261. These observations suggest that the forces of electricity which produce magnetism are indeed related to the permittivity and permeability of free space, and that these quantities are exerted by an apparent vacuum. Thus the effects of magnetism could be explained by none other than the phased effects of gravitational waves on the space-time lattice. 0262. Electromagnetism is of further interest to quantum gravity, particularly if we combine the standard equations B equals N0 P2 near and B equals NOEdV euro. Substituting for B we have ITR equals cov 46. 0263. Thus 2 near is proportional to the inverse of O. Thus as space-time is dispersed by gravitons, the permittivity field will increase in the same way capacitance increases with separation of plates. Because of the inverse relationship between E0 and 2 near, as 0 euros increases the circumference of a circle and the apparent ratio of n is to r, will appear to diminish in accordance with general relativity. This not an actual diminution in the circumference of a circle but the effective reduction of the resistance to motion in a circular path in this field. 0264. Incidentally, the above observations also lead us directly to Schrödinger's formula for the average equilibrium. April 6, 2006. Riem distance, r, between an electron with charge E, in orbit around a proton, which is conventionally given by r equals n 247 chains 2EO, in a 2.0265 where euro O is again the permittivity of free space, m is the mass of the electron and n is an orbital integer, h is Planck's constant and E is the charge of the electron. Furthermore, if E equals 0 euros per 3/4 NC3, 1/2 EQ, 3, then the equation at n equals 1, for the electron orbital radius elegantly simplifies to r equals 4h2c3 per meters. 0266, hence the orbital radius of the electron is related to spin of the electron, h, and its mass, m. 0267, quantum gravity and the charge of the electron. 0268, the equation for the charge of the electron, EQ, 1, contains the term SO, permittivity of free space, which according to these observations should vary in a gravitational field. E equals K0 thirds 4/30 TC3, 11/2, 6a. 0269, if we combine the standard equations B equals N0 P2 near and B equals NOEdV euro, substituting for B we have ITR equals cov 46. 0270, thus 2 near is proportional to the inverse of O. Thus as space-time is dispersed by gravitons, the permittivity field will increase in the same way capacitance increases with separation of plates. Because of the inverse relationship between 0 euros and 2 near, as 0 euros increases, the circumference of a circle and the apparent ratio of n to r will appear to diminish in accordance with general relativity. 0271, thus euro rises when space-time is dispersed by the gravitons that produce the gravitational field. This occurs in a similar way to the process by which capacitance increases with separation of plates in a capacitor. 0272, nevertheless, as c is a constant and as c equals n00 euros minus 1/2, then if euro rises then no falls. This is entirely consistent as no, which represents the force the quintessence exerts, would be reduced if the quintessence space-time lattice is dispersed. 0273, furthermore, as n0 equals 4nx 10 to 7na minus 2, then as no falls, then the apparent Russian n to r also falls in a gravitational field. This is largely the same as stating, as does general relativity, that the apparent radius r rises in a gravitational field. So this view is consistent with general relativity. 0274, nevertheless, to derive an exact value for the charge of the electron we must account for gravity in the above equation. We will take the specific example of the Earth's gravitational field in order to obtain the exact value for the electron. If in accordance with standard general relativity, the apparent increase in radius r is r equals gm, 3c2, 34. 0275, then given that the mass of the Earth is 5.9745 by 1024 kilograms, then E equals 1.47864 x 10^3 m, thus ITR equals 9.29057 x 10^3. 0276, which is the incremental factor by which euro must increase in Earth's gravitational field. So to correct 0 euros to account for gravity, 0 euros must be divided by the incremental factor, ITE. Similarly, as effectively n decreases in a gravitational field, to correct n to account for gravity it must be US 2006 00739766L17 multiplied by this incremental factor. So the equation for an electron in a zero gravitational field is E equals K0 thirds 4 thirds AC3, 11 halves plus 1 plus 2 AB equals 1.6022 x 1019c, 6b. 0277, this now gives the charge of the electron as measured in a zero gravitational field as 1.6022 x 1019c, which is the same as that measured on Earth. Notably, these observations appear to suggest that the charge of the electron is the same irrespective of the gravitational field. 0278, virtually unlimited degrees of accuracy for the charge of the electron and for the fine structure constant, may be achieved by taking into account second and nth order gravitometric effects. Thus, if we take into account the effect of gravity upon the radius of the Earth, it is also important to take into account an effect upon the instruments with which we measure quantities. This would be a second order gravitometric effect. Thus, taking into account second-order effects, we have a very small, but nevertheless relevant change, such that r equals E, 1 plus 2r. Thus 2r equals 9.3180486 x 10^3, and thus E equals K0 thirds 4 thirds AC3, 11 halves plus I plus 2RIL equals 1.60217665 x 1019c, 6c. 0279, this agrees exactly to the nearest 7 decimal places with the maximum accuracy of the experimental value for the charge of the electron. Furthermore, by taking into account the nth order gravitometric effect, it is theoretically possible to predict accuracy for the charge of the electron to 3n decimal places. This mathematically accuracy confirms the structure of the electron from first principles and indeed the theoretical effects of gravity on the permittivity of free space, E0. 0280, this returns us directly to the fine structure constant for the electron, which is conventionally given by E equals E2, Hc4 neo. If E equals E2 equals E0 thirds, 4 thirds equals 3, accordingly the quintessential equation for A is structurally given by 27, E equals MQ 32, where 0 equals 4 thirds NC3. See the structure of the electron and matter, we must now take into account the effects of gravity, as above thus. 2RR, MQ, 30, 2 plus 127, O2 equals 0.007297353. O281, where the gravitational term for the increase in radius r allows the mathematical derivation of r equals 0.007297353, and the above equation is in agreement with the conventional experimental value for r equals 0.007297353 to the nearest 9 decimal places. O282, hence the term 1ITR2 is in accordance with these observations for the effect of gravity on electromagnetic forces. To a maximum accuracy governed by current knowledge of the mass of the Earth and the gravitational constant, and thus the term for the gravitational increase in radius r. These observations can also be used to accurately predict the magnetic moment of the electron. O283, thus the presence of the fine structure constant can now be further understood by deriving the constant from IFRST principles, specifically from the actual dimensional conformation for the charge of the electron, E equals euro degree 3 4 thirds NC3 1/2 EQ 6. O284, overall the fine structure constant allowing for the term r, which is the general relativistic increase in the radius of the Earth due to gravitation, is given by none other than the formula for the mass of quintessence and from the structure of the electron, which can now be derived from IFRST principles to 7 decimal places or more. April 6, 2006. O285, quantum gravity and the electron magnetic moment. O286, the theoretical origin and nature of magnetism remains obscure in current electromagnetic theory. An explanation suggests these magnetic effects are produced by photons, although no photons have ever been observed. To get round this difficulty, it is postulated by physics that magnetism results from virtual photons. However, Maxwell's equation for electromagnetism states that the photon has no net magnetic effect. Ablobi, C plus SBAZ equals 0. O287, thus magnetism could not by the above standard equation be derived from a photon real or virtual. O288, in addition, observational data suggests that black holes have powerful magnetic fields, and as in theory photons are unable to escape from black holes, except for small quantities in the form of Hawking radiation, it would be difficult to explain these magnetic fields on the basis of photon emission. O289, Einstein postulated that magnetism was merely due to special relativity. Sub, Ref 17. The postulate for the nature of magnetism in these current observations states that the magnetic force results from relativity due to none other than the phased emission of gravitons. Y postulate two invisible forces, magnetism and gravity, when one, the graviton, will do. This view, as previously discussed, quantum gravity and electromagnetism, is entirely compatible with standard relativity 19. Thus, with the graviton origin of magnetism, the equation for the magnetic moment of the electron should have an expression in terms of quintessence and in turn the gravitational force and in particular the graviton. 0290, the standard term for the magnetic moment of the Bohr magneton, SIB, is T B equals A, 4 am. 0291, in standard quantum mechanics the Bohr magneton, dB, however, needs to be corrected to agree with experiment. The correction factor is termed E, where E equals at 270 minus 0.328 at 2/7 C2 equals 0.00115961. Thus theory reveals U, the magnetic moment of the electron where T equals A, 4 am, 1 plus, at 2A, minus 0.32882, A2. 0292, the conventional derivation of the term E above is given from the fine structure constant, at 2n, which is theoretically consistent. However, a rather arbitrary mathematical correction term, 0.32882, N2 needs to be used in this standard equation. This appears ad hoc and needless to say, more accurate measure. Ments show the electron magnetic moment to the Bohr magneton ratio, 1 plus E equals 1.001159652, which suggests the correction factor is indeed incorrect. Nevertheless, this correction factor is essential for renormalization, and thus for quantum mechanics to work. 0293, quantum gravity readily explains the discrepancy between the theoretical Bohr magneton, TB, and the actual measured magnetic moment of the electron, 0. In accordance with the above chapter, quantum gravity and the charge of the electron. 0294, thus the significant mathematical discrepancies can be removed by accounting for the effects of quantum gravity. US 2006, 007397 Al 18. 0295, thus taking the charge of the electron, E, using the equation for the Bohr magneton and the effects of quantum gravity such that gravitational change in radius is R. The magnetic moment of the electron is given by T equals A, 43 TME, 14A, I plus 1 FR. 0296, this gives an electron magnetic moment to Bohr magneton ratio of 1.001159668. Thus the mathematical term for the magnetic moment of the electron is given, avoiding the arbitrary and dubious term 0.32882, N2 used in the standard equation, simply by accounting for quantum grav ITY. 0297, it is now possible to unite the equations for gravity and magnetism by substituting the fundamental key equations of quantum gravity. Thus if H equals 3mqc2 eq pound and m equals mqnq eq 2, then we can express the magnetic moment of any particle with the charge of the electron, including the proton, in terms of the number of quintessences, nq, in that particle. Ht equals ec2, 4/33 eng 47. 0298, given that the postulated structure of the graviton. April 6, 2006. Explain cosmic inflation and the flatness of the universe. The quintessence must shun, or be shunned by, matter. 0303, in descriptive terms a body close to a large mass will have a tendency to move toward it because the three-dimensional lattice would be less dense as it approached the surface of the large mass. Overall, there would be less resistance to motion in the direction of the large mass, and the motion in this direction would be facilitated by the vibration of quintessence. 0304, in general relativity the principle governing motion is the geodesic of least distance. This can be re-expressed using similar equations using least action. Furthermore, the concept of motion due to the vibrations of quintessence is more logically and experimentally compelling. 0305, these observations can now be used to link general and special relativity. Thus, as we approach the speed of light, the mass of an object traveling through the space-time lattice would approach infinity, directly because the number of quintessences passing through a body would increase with increasing velocity, hence the equation mr equals m0, 1 underscore 2, c2, 1 half. 50 is p equals ac, c, eq, 42, then substituting we have ht equals 3c, 4, 1, nc, or 48, 10 eo1, m equals mo, 1, v2, 50a. 0299, showing that the equations for the magnetic moment are compatible with the gravitational equations given earlier. Principally, the quintessential equations now allow the determination of the magnetic moment of any charged object from the equation for the graviton and directly from the number of quintessences it contains. In conventional physics, the magnetic moment of the electron requires a correction factor, 1 plus, 1 cc, minus 0.32882, to derive the correct experimental value. These observations herein indicate that the correction factor is more logically 2.0306. In turn, this would generate increasing gravitons, and accordingly this would explain the observed effects of special relativity. Time itself is due to passage through the space-time lattice, and where the space-time lattice is dispersed by gravitons, time and length are reduced with increasing velocity and hence increasing space-time lattice dispersion, similar to the way in which gravity alters space-time. 0307, as a result, T equals underscore V2, C2, 1 half, L plus R, W. Here R is the general relativistic increase in radius 1 underscore V2, C2, 1 half 1, around a gravitational body. This suggests that magnetism is 0308, thus resulting in the effects of special relativity. Not only affected by gravity, but can, as shown as above, be derived using the quantum gravitational equations. 0300, quantum gravity and special relativity. 0301, ordinary matter passing through the lattice would produce gravitons which would interact with space-time as described by general relativity. The quantity of gravitons would be determined by the apparent mass, and in turn these would apparently curve space-time. The geometry of this curvature is elegantly described by general relativity using Riemann geometry, specifically using metric tensors. Intriguingly, the metric tensor is not a single number, but at each point in space-time it is required to consist of a collection of 10 numbers. Consequently, 10-dimensional space-time hypotheses, such as this or superstring theory, may automatically yield general relativity. 0302, general relativity is indeed very elegant, nevertheless there was a logical step yet to answer. That is, how do gravitons shape space-time? This can now be readily answered by considering the interaction of a three-dimensional space-time lattice with gravitons themselves to produce the effects of gravity. The effects of gravity are as such to compel a body in motion towards the gravitational object and to a much smaller extent vice versa. This effect can only be produced if gravitons repel quintessence, the constituents of the 3D lattice. Indeed, it has been stated that in order to 0309, quintessence and black holes, 0310, to address the relationship of the space-time lattice to gravity directly, it is important to discuss the concept of quintessence with regard to general relativistic equations. The standard general relativistic equation for the apparent increase in radius, r due to the curvature of space-time around a gravitational object, which has also been previously derived from first principles, EQ 36, is r equals gm 3c2 34 0311. This can also thus be written as 3R equals Galileo 51. 0312, this standard equation is in keeping with the above observations. Specifically, as the mass increases, E0 increases, in turn the radius will appear to increase relative to it. 0313, the above observations now allow us to examine the effects with regard to the interior of black holes themselves. The event horizon would represent a critical density for quintessence, in which light could not escape. The Schwarzschild radius would now be given by Rs equals 2 gm Luo 0314. The event horizon will occur at the point at which there is less resistance to circular motion than motion in a US 2006 007397 L19. Straight or partially curved line. Given that n is proportional to 1, 0 euros. The event horizon should occur when the permittivity has increased by a factor of n. 0315, effectively because the permittivity of free space rises, n decreases. This is entirely in keeping with general relativity, which predicts the effective change in the ratio of the radius to the circumference as given by the conventional equation, where r is again the apparent change in radius. R equals gm, 3c2. 0316, hence n will effectively decrease as we approach the event horizon of a black hole. When n decreases to 1, the circular circumference is equal to the diameter, and moreover, inside this limit it is shorter for light to travel in a circle. Thus light cannot escape the event horizon. 0317, this can give us great insights into the workings of space-time. For flat Euclidean space the standard equation is n equals -1. 0318, in accordance with general relativity, the ratio of the radius to the circumference changes in a gravitational effect, and effectively n equals 1, at the event horizon. Thus the boundary condition for the shape of space-time at the event horizon now has the direct equation of 0319, with E. In a black hole, as the permittivity of space increases by a factor of 27c, an object within it will complete 2 rotations rather than travel in a straight line, in effect exceeding the speed of light by 2n. Hence, the condition for space-time is represented by the equation E2:0320. Thus, an increase in the permittivity of free space by a minimum factor of n to produce a black hole is estimated to result from an increase in mass by a factor of approximately 106, the ratio of the mass of the Earth and that of a putative black hole. 0321, continuing with the subject of a black hole, according to the model inside the black hole, the gravitons produced by the matter present would be in equilibrium with the density of the space-time lattice. Increasing the rate of rotation of the matter in the black hole, for instance, would thus increase the production of gravitons and its effective mass and increase the radius of the event horizon. A density gradient of the space-time lattice would continue to exist within the black hole. Progressively closer to the center of a black hole, matter itself would be increasingly compressed and the spherical structure of the quasi-electron would be predicted to collapse. This collapse would result in the formation of an exotic form of matter in the form of pure quintessence in a black hole. 0322, this pure quintessence would produce the singularity at the center of the black hole. The larger the black hole in terms of mass, the more pure quintessence would exist at its core. 0323, quintessence and the Big Bang. 0324, quintessence theory not only predicts the occurrence of the Big Bang, but allows a prediction for the value of the entire mass of the universe from first principles. April 6, 2006. 0325, in accordance with quintessence theory, the Big Bang resulted from the explosion of an immense black hole singularity, which was constituted from pure quintessence. 0326, on the basis of quintessence, there will be a critical mass for Big Bang event. Thus, if entire space-time between quintessence is compacted so that no further quintessence can be accommodated, the addition of further quintessence would destabilize the immense black hole, resulting in the Big Bang. 0327, it is possible to predict this critical mass, using the radius of quintessence as a benchmark. Given the 9 spatial parameters present in the metric tensor, used in general relativity, we find that the actual formula for the radius of quintessence, RQ2, is mathematically in agreement with general relativistic theory when 9R2 equals GH C633. 0328, this again supports the 9-dimensional view of space, so crucial in superstring theory. Moreover, the size of the vibrations of quintessence can thus be calculated as RQ equals 1.35 XIO minus 35 meters 33A. 0329, the volume of each quintessence is thus 4/3 ARQ3 equals 1.0306 XIOM4M3 33B. 0330, so to be accommodated within unit volume of space-time, with no intervening apparent space-time, given that each of 9 overlapping quintessences are required, would require approximately 9x 10,104 quintessences. 0331, as the mass of quintessence is MQ equals H, C2 equals 7.373 x 10. 51 kilograms sec EQ. 1. Then the mass of the universe, to 2 decimal places, is 1.18 x 1053 kilogram, 33 C. 0332, this is in close agreement with a recent estimate of the mass of the universe from COBE and other satellite data, which estimates the mass to be 100 trillion tons, 1053 kilograms. 0333, moreover, the early formation of the galaxies can be readily explained. It is likely that in such a Big Bang some very small black holes might have prevailed and that these formed the seeds of the galaxies we see today. 0334, the event horizon, calculated from the Schwarzschild radius, of such an immense black hole is about 1026 meters, which would have allowed Guth's inflationary component to the early expansion of the universe. 0335, in addition, inflation may result directly from the observation that once electrons have formed from the primordial soup of quintessence, they emit gravitons which in turn repel space-time, which might also result in another cosmic inflationary cycle. 0336, most importantly, quintessence theory explains the Big Bang from first principles and is capable of accurately predicting the mass of the universe. 0337, the nature of energy. 0338, these observations allow a fundamental understanding of energy. The quantum physical minimum component of energy is Planck's constant, h. To define the minimal component of mass, using the standard energy equivalence formula, E equals mc2, such a minimal mass, mg. US 2006 00739760L20. Would be required to have the value equivalent to MCI equals HC2. 1. The total mass of a system, M, would then be M equals Mach and C, where NQ is the number of these minimal units. Thence, the total energy of a system can be derived from the minimal energy, H, multiplied by the number of these energy units, Lig. Thus as E equals mc2, then also E equals Mach and Sig2, and substituting mci equals hc2, the energy equivalence formula has the more logical formulation. E equals hnq, the 0339, thus the energy of a system is equivalent to the minimal energy unit, H, multiplied by the number of those minimal energy units, nq. 0340, this leads directly to a deeper understanding of wave-particle duality and the wave nature of matter. 0341, this is encapsulated by the quintessential energy formulae. 0342, as conventionally 13E, C equals P, then K equals HP equals HC, Phi, 2, and E equals HNQ, then K equals C, link to B. 0343, importantly, as indicated by equation 2b, energy having no quintessence would have a wavelength of infinity y. Specifically, pure energy containing no quintessences would have a lambda of infinity. According to quantum mechanics, an infinite wavelength would result in the probability of that energy being anywhere. As energy itself has no electrical charge, it would not be impeded by the permittivity and permeability of the three-dimensional space-time lattice. Moreover, energy would not be detectable in three-dimensional space-time, unless it interacted with matter, as in the EPR experiments. Indeed, energy is not observed when not bound to any form of mass or particle. 0344, thus equation 2b, takes us to our original assertion regarding the existence of pure energy. 0345, energy is not bound by the space-time lattice. 0346, thus, as the EPR experiments suggest, the ENCE of energy separate from matter and thus separate from the three-dimensional space-time lattice, it is interesting to IFND that experiment suggests the existence of free energy in a continuum separate from space-time and matter to produce the effects of quantum teleportation. 0347, this is not, however, teleportation across an additional dimension. This is a term to describe in partially familiar terms the dissociation of energy from the three-dimensional space-time lattice. As time is inextricably linked to each dimension of space, the effects of energy would be inextricably linked to the events, such as the creation of virtual particles, we see interacting within space-time. It is unlikely that observers have any direct day-to-day experience to explain quantum events. Nevertheless, quintessence theory may have given us a window into the hitherto hidden workings of the universe. Thereby, the mystery of the uniformity of the universe, across distances which the speed of light could not apparently traverse, is readily explained by the fact that the free energy contained in the universe is not bound by the space-time lattice. April 6, 2006. 0348, in the case of light, due to the exceedingly small masses involved, there would be relatively easy exchange of matter with free energy within a photon. This would make the photon the ideal experimental tool to look for energy which is not bound by matter and in turn energy which is not bound in space-time. Indeed, very recently Furusawa et al. Have reported to have observed the transference of energy as photons from A to B, without those photons traversing space-time. This finding, which has been supported using other experimental techniques, is very important as it suggests the existence of such free energy. 0349. Overall, quintessence theory gives an a priori explanation for the concept of mass, the elementary particles, the forces of nature and quantum effects. It can equally be used logically to explain the inner physics of a black hole, the missing mass in the galaxy, the expansion of the universe, Guts inflationary theory, and predicts the Big Bang, from first principles. 0350, Part 4, Applied Theory with the intent to create closed time-like curves. 0351, Electron bombardment of the photosphere to induce gravitational shift. 0352, leveraging the above relationship between mass and quintessence, we derive that if an electromagnetic radiator Tn with velocity v strikes the event horizon singularity of rest inertial mass m, and u is the electromagnetic energy absorbed by the singularity, then, according to Maxwell's prediction, a momentum q equals u, v is transferred to it. Mass shift dmb, dependent on the external electromagnetic energy, equals the inertial mass shift dependent on the increment of energy in the particle. Since in this case the inertial mass shift does not depend on velocity v, i.e., it is related only to the momentum q absorbed, it can be obtained by making p equals 0 in variation r equals h equals c, q 101.1011, 2 mc, 2 from the particle's inertial Hamiltonian. Consequently, the expression of drap is w retinas equals R1C2 equals 1 plus U, Mike 2 EGUG, 2, 1 over 1 plus D, WS2 plus 1, 2 equals 1. 0353, comparing now the expression of ML and MG, we have MG equals M12 dMB. By replacing me in this equation, given by equation above, we obtain the expression of the correlation between gravitational mass and inertial mass, i.e. equals M, for 1 plus U per meter, C2 kgug, 2, D, we, 2 plus 1, 2 to 1, M. 0354, we see that only in the absence of electromagnetic radiation on the event horizon, U equals 0, is the gravitational mass equivalent to the inertial mass. Note that the electromagnetic characteristics, E, M and S do not refer to the singularity itself but to the outside medium around the singularity, photosphere, in which the incident radiation is propagating. US 2006, 00739760L21. 0355, stable CTC solution from modified M theory. 0356, our innovation is a method of creating an event where a dual membrane or dual boundary condition exists. We do this using generalization from a Misner space which has been modified if one analytically continues the maximal extended Misner metric so that ds equals do2 plus dw2 plus dx2, 2 plus dx3, 2 to the Euclidean section so that u equals iota zeta. We obtain a Misner instanton on the section where w and zeta are both real. The Euclidean time, t, and the closed space-like coordinate are both periodic, the later having a period of 211 t2. Going back to the Lorentzian sector, we find that the period of the closed coordinate becomes linearly dependent on the physical time. Using automorphic fields in the Hadamard function, one can obtain a quantized condition for time. This gives us a figure on the order of the Planck time. This confines such a stable wormhole condition to the general area of the Planck scale in its modified form, which is that area defined by the membrane itself. As such, these Planck scale wormholes are the true source of the true virtual aspects of the vacuum and quintessence. The effects of the dual singularity system can be viewed as an overlap zone of two distinct space-times which have boundary conditions on both sides. As an object accelerates towards C, it is this same boundary or horizon that object encounters when the time-defined horizon solution for the universe is imposed. At this point, drawing upon Van den Broek's alterations for this space-time geometry to create a single closed Friedmann-Roberts-Sun-Walker spacetime, the space-time geometry can be represented by this equation: ds equals dct2b2, dx3 fdct, 21 plus dy2 plus dz2b can be any function that is large near the displacement device. We then consider this transformation as extended to four-dimensional space-time with arbitrarily time-dependent acceleration. We also present the device frame energy density 2 from a 4-dimensional calculation and note that the 4D classical calculation is everywhere finite. 0357. Consider an Alcubierre interval given according to a remote frame's cylindrical coordinates by ds2 equals 1 to 112 fdct2 plus 2b fdct dz dz2 dr 2r2 df2, where f is a function that is 1 at the location of the device and 0 far from it. 0358. Starting out with the first transformation z equals z October beta dct, where b is first expressed here as a function of time court. With some algebra for simplification, this results in ds241, 112, 14, 2 dct2 to 2b, 1 for dads dz2 dr 2r2 df2. Let g equals 1f and this becomes ds2 equals 1 to 112 g2, clay 2 to 2b g dct dz dz2 dr 2r2 d1. 0359. Notice that this returned the original interval's form with a reversal on the sign of b and a reversal of the boundary conditions for g. Now we notice that at r equals 0, this interval becomes the interval for special relativity transformed to cylindrical coordinates. Thus, we have found a transformation to a frame-based local to the device. One can also verify that in these coordinates the relevant affine connections vanish at r equals 0. A further proposed modification to this field, we will reintroduce a time dilation term into the device's frame's interval. Only we will use different bound ARY conditions for it. We will keep A equals 1 both at the location of the device and far from it, but allow it to become large in the warp region. This is achieved by the simplest means possible in the proposed field generation method. Since rotating Kerr singularity under bombardment would produce, April 6, 2006, an equal negative energy region, with the effect focused outward away from the device slightly by the relative alignment of the Kerr singularity, the actual inward-going portion of such fields would overlap and cancel their effect out in the region of the device. This yields a space normal time region, which is again restored at the fringes of the outward-going field. From the standpoint of a geometric picture of space-time around the device and extending outwards, one has actually created a dual event horizon situation as far as time goes. The inner one is the shell of the cancelled out field inside of which normal time flow is restored. The outer one is formed at the boundary where normal time resumes and within which we have a negative energy field. Summary of the invention. 0360. The present invention is a method for the generation of a pseudo 2 plus 1 dimensional anti-de Sitter space Dideo and got 2002, using two Kerr-type positively charged rotating dilation singularities where one singularity is maintained as her axis of rotation or reference singularity, and the other, target, singularity is subjected to a differential electron flow so as to simultaneously pass above the photosphere of said singularity in its direction of rotation prograde orbit and contrary to its direction of rotation retrograde orbit to release a directed flow of gravitons in a sinusoidal oscillation simulating a rotational effect of the target singularity around the axis of rotation provided by the reference singularity, resulting in the creation of time-like curves in a compact time-oriented manifold permitting topology change from one space-like boundary to the other in accordance with Gerode's theorem, Gerode 1967, which results in a method for the formation of geodal-type geodesically complete spacetime envelopes complete with closed time-like curves. Brief description of the drawings. 0361, Fig. 1 is a schematic representation of the mechanism employed to house the components necessary to generate a 2+1-dimensional anti-de Sitter space, resulting in the creation of time-like curves in a compact time-oriented manifold. 0362, Fig. 2 is a schematic representation of the geodal type geodesical. Y-complete space-time envelope created by the mechanism complete with closed time-like curves. Detailed description of the invention. 0363, Principles of Gravity Distortion Time Displacement Systems. 0364, the theoretical understanding of quantum gravity allows the design of time displacement systems from first principles. It is unlikely that gravitons or Kerr singularities can be controlled in a precise way using current technology. Nevertheless, an understanding of three-dimensional space-time and matter does allow the design of elementary displacement systems. That is, systems whose displacement rely on direct warping space-time as opposed to the ejection of material to provide thrust resulting in time dilatational effects. 0365, the background for these systems are already partially understood and quintessence theory allows their US 2006 007397 al. Further development. For this invention, the formation of black holes in the laboratory represents a crucial step in understanding the mechanisms that underlay gravitational physics and in turn the warping of space-time. The existence of black holes permits the localized application of the axial torsion spin rotation coupling effect Jang and Beesham 2002, resulting in a rotating frame with relativistic factor, Jang 2003, which can be used in the creation of a Alcubierre space-time bubble under the Van den Broek modification of the Alcubierre geometry, Van den Broek 1999. Resulting in a method for the generation of a pseudo 2+1-dimensional anti-de Sitter space, Dideo and Gott 2002, using two Kerr-type positively charged rotating dilation singularities where one singularity is maintained as their axis of rotation or reference singularity, and the other target singularity is subjected to a differential electron flow so as to simultaneously pass above the photosphere of said singularity in its direction of rotation and contrary to its direction of rotation to release a directed flow of gravitons in a sinusoidal oscillation simulating a rotational effect of the target singularity around the axis of rotation provided by the reference singularity. In this instance, the space-time lattice would be repelled by gravitons in such a way as to disperse space-time quintessence in a circular fashion around each of the singularities, producing multiple event horizons around the simulated axis of rotation provided by the reference singularity. 0366, the release of gravitons from the target singularity is controlled by differentially governing the electron flow across the photosphere with the use of powerful electric currents. In turn, the differential direction of flow across the photosphere of gravitons would determine the direction of motion through the space-time lattice and the resulting time displacement from one space-like boundary to the other in accordance with Geroog's theorem, Geroog 1967. When implementing this approach, it is important to remember that the black hole is not excited by the smashing of the clump as it hits the horizon. The hole is rather excited when the metric perturbation associated with the clump is felt by the background metric. The excitation event therefore constitutes a smooth process whereby infall of a clump from .rmb and through R+ serves as a source in the Tucholsky, 1973, equation for small perturbations to the Kerr geometry, with appropriate boundary conditions at R+ and ρ. This is an important distinction with a great deal of relevance to the practical engineering of the displacement unit since we need to gauge the driving of QNR modes in terms of an E_active coupling from clump infall. 0367, what results is a method for resonant driving of the quasi-normal ringing, QNR, wave modes of the Kerr geometry of the target singularity. The micro-black hole hyper-accreting at rates Ym. 1 msec, 1 from a neutrino-cooled disk is pushed through to oscillate near resonance of its 1, m equals 2 quadrupole QNR frequency due to the infall of compact mass over densities from the cusp in E_active potential on a dynamical time scale. This mode is induced via induced magneto-rotationally induced fluid dynamics in the ultra-relativistic region of the flow bounded from below by the marginally bound orbit radius, RMB. If the QNR modes are fed resonantly for a few seconds of hyperaccretion, the enhanced amplitude of the oscillations yields a very high rate of energy deposition into gravitational waves. Indeed, the integrated energy deposition is large enough to evaporate the equivalent of a factor of a few times the total rest. April 6, 2006 22. Mass energy of a single clump into gravitational waves, which in turn interact with the reference singularity. 0368, application of the method described in the preview US section results in translation outside of the cosmological horizon, where fr less than 0. The topology of the resulting geodesic, for large constant r, is mathematically equivalent to a Euclidean cylinder of the condition Rxsn where t is the coordinate along the cylinder. It are located outside the future, past cosmological horizons, where r is time-like and t is space-like. In the case of a rotating Kerr black hole, there are two circular photon orbits that can exist in the equatorial plane and be exploited to create a Tipler sinusoid. One is a prograde orbit moving in the same direction as the black hole's rotation, while the other is a retrograde orbit moving against the black hole's rotation. Their radii are respectively given by R1 equals 2m, 1 plus cos 2/3 r cos LAVM, R2 equals 2m, 1 plus cos 2/3 r cos QM, where A is the angular momentum per unit mass of the black hole. The orbits fall in the range m greater or equal to RL greater or equal to 3m greater or equal to R2 greater or equal to 4m. The fact that a prograde photon or in or case Cooper pair with Bose characteristics orbits the black hole at a smaller radius than a retrograde one can be attributed to the well-known Lenz-Thirring effect, i.e., the dragging of inner teal frames due to the black hole's rotation, which we control and influence via electromagnetic-induced load coupling with the open magnetic field lines threading the BH horizon. This dragging would cause charged Cooper pairs to revolve around the black hole relative to a static observer at infinity. Thus, to such an observer, a prograde Cooper pair would have to orbit at a smaller radius to compensate for the extra angular momentum acquired, while a retrograde one would have to orbit at a larger radius to compensate for the lost angular momentum. Indeed, in the limit of zero rotation, these two orbits coincide at RD3m, giving the single circular orbit of the Schwarzschild black hole. Now, recall that orbits around the Schwarzschild black hole are necessarily confined to a plane passing through its center, because of the spherical symmetry of the space-time. However, the Kerr black hole space-time has only an axial symmetry, in addition to being stationary, and this raises the possibility of non-planar orbits. One could, for example, contemplate the existence of spherical boson orbits with constant coordinate radii that are not necessarily confined to the equatorial plane around the Kerr black hole. Such orbits would be a non-trivial generalization of the two circular photon orbits that lie in the equatorial plane. At first it may seem a little surprising that such spherical orbits could even exist, but there is an interesting reason as to why they are possible. Note that an object in a spherical orbit would, in addition to moving around the black hole in the azimuthal direction be undergoing some periodic motion in the latitudinal direction. This is only possible if there is a conserved quantity associated with motion in this direction, just as angular momentum is necessarily conserved by its rotational motion in the azimuthal direction. This result can be seen, for example, using action angle variable. Now, because the curve space-time has only axial symmetry, geodesics in it should have only two constants of motion, namely energy and angular momentum. However, Carter discovered the remarkable fact that geodesics in the Kerr space-time possess a third constant of motion. It turns out that Carter's new US 2006-007397-6L23 constant governs the motion of geodesics in the latitudinal direction, although it is not related to any obvious space-time symmetry. Thus, spherical time-like orbits, which assume eigen-like properties around the Kerr black hole, are possible, and when coupled with charged bosons may be exploited to manipulate the relative event horizons of the target singularity. The location and the temperature of the modified event horizon depend on the time, charge and angle of incidence of the Cooper pairs. The Fermionic spectrum of Dirac particles displays a spin-rotation coupling effect due to the interaction between the particles with spin 1 equals 2 and the black holes with rotation. The effects arise from the interaction between the spin of Dirac particles and the rotation of the evaporating black holes. The feature of this spin-rotation coupling effect is its dependence on different helicity states of coupled particles with spin -1/2 and its irrelevance to the mass of particles. 0369. In order to design a mechanism for time displacement exploiting the Carter asymmetry cited above, we utilized two positively charged top-spin rotating Kerr-type black holes aligned on demand to create a simulated rotational effect around a central axis provided by the reference singularity. In the case of the Kerr black hole singularity, this is accomplished by an inverse Blandford-Zajac (BZ) process utilizing the magnetic flux of open field lines connecting the horizon and an induced remote load. Ding-Chun Wang, Can-Seo and Wei-Hua Lei, 2001, permitting the microscopic black hole singularity to be rotated along its horizontal axis in at relativistic centrifugational speeds. A differential current is then applied in such a way as to pass through the entire photosphere in the desired direction. As a result, the gravity field can be manipulated by three factors that affect it in distinct ways. Adding electric charge to the singularities increases the diameter of the inner event horizons. Adding mass to the singularities increases the area of gravitational influence around the singularities. Rotating and positioning the polar axis of the singularities affects and alters the resulting gravity sinusoid. 0370. In order to create a sinusoid capable of inducing a topology change from one space-like boundary to the other in accordance with Gerode's theorem, the electric charge in the upper half of the photosphere would be maximized. The electrons will have a vector in the left to right direction as the singularity spins clockwise. If a maximized current is applied to the singularity in the same direction, this will result in an increase in the velocity of the electrons relative to the center of gravity of the singularity, due to the flow of current. In turn, according special relativity and to the space-time lattice model, this will result in an increase in the relativistic mass of the electrons and in turn by general relativity an increase in the release of gravitons. 0371. Conversely, in the lower half of the singularity, the electrons will have a vector of motion in the right to left direction due to the spin of the singularity. This will be relativistically slowed by the differential current applied in the same direction as the current above, and hence in the opposite direction to the direction of rotation. The charge can be separately applied and adjusted to ensure that the electrons are relativistically stationary relative to the center of gravity. In turn, this will minimize the relativistic mass and result in a decrease in the release of gravitons for the lower half of the singularity. April 6, 2006, 0372, the overall result will be a greater release of gravitons in one direction and a lesser release of gravitons in the converse direction. The effect will be enhanced by the use of a multiphasic current simultaneously applied. This will result in the release of multiphasic gravitons which will disperse space-time in the singularity with increase in density. In the converse, this effect can also be produced and supplemented with the use radio frequency pulses. The radio frequency pulses must be designed to produce a change in the spin of the particle to enhance the release of gravitons in the desired direction. 0373, with the use of large currents, the drift velocity of the electrons across the photosphere could be greatly increased. Within this region, the electrical resistance is virtually eliminated, thereby allowing large currents to be induced with minimum total power output. 0374, the result is the production of Cooper-paired electrons of high speed and hence high relativistic mass in the desired half of the singularity, whilst producing low speed and thus low mass paired electrons at the converse of the singularity, in accordance with special relativity. The imbalance in the rotating singularity will be continuously present, creating a dynamic warping of space-time. In effect, the differential current flow will produce differential graviton production and in turn, by general relativity, the warping of space-time. 0375, as the Cooper pairs cross the photosphere, a accretion of the Bose particles results. Near-hole accretion across the target singularity is then motivated by magneto-rotation ally-induced ultra-relativistic disk dynamics in the region of the flow bounded from below by the marginally bound geodesic radius RMB. As the particles impelled have high spin values, a largely coherent magnetic field in this region has the dynamical implication of compact mass segregation at the displacement nodes of the non-axisymmetric MRI modes. This results in prolific gravitational wave emission coincident with the gamma-ray stage. The gravitational wave emissions are then manipulated to influence the reference singularity to produce a variable gravitational sinusoid, which is then used to mathematically approximate the gravimetric distortion, inducing a topology change from one space-like boundary to the other in accordance with Jerok's theorem. Bibliography 0376 Mesoscopic behavior of the neutral Fermi gas 3 he confined in quantum wires. S. L. Philipson, A. M. Geno, S. N. Fisher, G. R. Pickett, P. J. Whitebo, Nature 395, 578 to 580. 0377, direct observation of d orbital holes and Cu-Cu bonding in Q. J. M. Zhao et al. Nature 401, 49 to 52. 0378, the foundation of the general theory of relative ity A. Einstein. Translated from Die Grundlage der Allgemeinen Relativitätstheorie, Annalen der Physik, 49, 1916. Published in Einstein, The Principle of Relativity, Dover Publications, 1952. 0379, Sidelights on Relativity. Ether and the Theory of Relativity, Albert Einstein. Dover Publications, 1983. 0380, Inflation is Dead, Long Live Inflation. George Musser, Scientific American, July 1998, p9. US 2006, 00739760 al. 0381, The Flip Side of the Universe. George Musser, Scientific American, September 1998, p13. 0382, The Fifth Element, Marcus Chown. New Scientist, April 3, 1999, pp 29 to 32. 0383, The Quantum Universe. Tony Hay and Patrick Walters. Cambridge University Press, 1987. Solving the Schrödinger equation, pp. 165 to 167. 0384, Complex Numbers, Mathematics for Engineers. W. Bolton, Longman Scientific and Technical, Chap. Introduc. In Complex Numbers P1 to 11. 0385, Unconditional Quantum Teleportation. A. Furusawa, I. Sorensen, S. L. Braunstein, C. A. Fuchs, H. J. Kimball, E. S. Holzig. Science, October 23, 1998. Volume 282, 706 to 709. 0386, Complete Quantum Teleportation Using Nuclear Magnetic Resonance. M. A. Nielsen, E. Nil, R. Laflamme. Nature, November 5, 1998. Volume 396, 52 to 55. 0387, Experimental Quantum Teleportation. D. Bouw Meester al. Nature 390, 575 to 579, 1997. 0388, Experimental Realization of Teleporting an Unknown Pure Quantum State via Dual Classical Anine. Stein-Podolsky-Rosen Channels. D. Bosky, S. Branca, F. De Martini, L. Hardy, S. Popescu, Phys. Rev. Let. 80, 1121 1125 1998. 0389, W. Tittle, J. Brendel, H. Juniden, N. Gissen, Phys. Rev. Let. 81, 3563 3566 1998. Into the Vortex. Charles. Seif. New Scientist, October 24, 1998, p7. 0390, Direct Observation of a Fractional Charge. R. de Pichotto, M. Reznikov, M. Hybium, V. Umansky, G. Bunnan, D. Mahalu. Nature 389, 162 to 164. 0391, Tables of Physical and Chemical Constants. K. and Leiby. Longman Scientific and Technical. 0392, Physics in Focus. Michael Bramicom. Section, Wave Mechanics, P521. Nelson Special Relativity. A. P. French. Nelson. Chapter 8, Special Relativity and Electricity, pp 256. 0393, Universe in Balance. Jeff Peterson. New Scientist 168, p27. 0394, The Accelerating Universe. Mario Livio. John Wiley and Sons, Inc. 2000. 0395, Escape from Earth, Charles Seif, New Scientist, Feb. 6, 1999, p6. 0396, The Discovery of the Top Quark. Tony Liss and Paul Tipton. Scientific American, September 1997, pp. 26 to 41. 0397, The Mystery of the Nucleon Spin. Klaus Ritz and Andreas Schaefer. Scientific American, July 1999, pp. 42 to 47. 0398, And Your Glue. Frank Wilczek. Nature, 400, pp. 21 to 23. 0399, The Warp Drive, Hyper-Fast Travel Within General Relativity. Miguel Alcubierre, Classical and Quantum. Gravity, Volume 11, L73L77, 1994. 0400, Photon Propagation in a Stationary Warp Drive Spacetime, Klaus R. Kramer, 1995. April 6, 2006 24. 0401. Some thoughts on the implications of faster-than-light interstellar space travel. A. Crawford, Quarterly, Journal of the Royal Astronomical Society, Volume 36, 205 to 218, 1995. 0402. Physical and cosmological implications of a PO's Sybil class of particles able to travel faster than light. Luis González Mestra's contribution to the 28th International Conference on High-Energy Physics, Warsaw, Poland, 1996. 0403. Warp Drive and Causality, Alan E. Everett, Physical Review D, Volume 53, 7365-7368, 1996. 0404. A superluminal subway, the Krasnikov tube, Alan E. Everett and Thomas A. Roman, Physical Review, D, Volume 56, 2100-2108, 1997. 0405. Quantum effects in the Alcubierre warp drive spacetime, William A. Hiscock, Classical and Quantum. Gravity, Volume 14, L183L188, 1997. 0406. The Unphysical Nature of Warp Drive, Michael J. Fanning and L. H. Ford, Classical and Quantum Gravity. Volume 14, 1743-1751, 1997. 0407. On the possibility of a propulsion drive creation through a local manipulation of spacetime geometry. Vessel and Petkov, presented at the 34th. 0408. AIAA, ASME, SAE, ASEE Joint Propulsion Conference, 1998. 0409. Operational, Energy Conditions, Adam D. Helfer, Classical and Quantum Gravity, Volume 15, 1169-1183, 1998. 0410. No Warp Drive D. H. Cool, Classical and Quantum Gravity, Volume 15, 2523-2527, 1998. 0411. Quantum inequality restrictions on negative energy densities in curved spacetimes, Michael John Fanning, doctoral dissertation, 1998. 0412. Hyperfast interstellar travel in general relativity. S. V. Krasnikov, Physical Review D, Volume 57, 4760, 1998. 0413. Superluminal travel requires negative energies, Ken D. Olam, Physical Review Letters, Volume 81, 3567, 3570, 1998. 0414. Hyperfast travel without negative energy, Eric Bed, 1999. 0415. Warp drives, wavefronts and superluminality, Eric Bed, 1999. 0416. A traversable wormhole, S. Krasnikov, 1999. 0417. Speed limits in general relativity, Robert J. Low, Classical and Quantum Gravity, Volume 16, 543 to 549, 1999. 0418. Null geodesics in the Alcubierre warp drive spacetime, The View from the Bridge, Chad Clark, William A. Hiscock and Shane L. Larson, Classical and Quantum Gravity, Volume 16, 3965-3972, 1999. Opening square bracket. 0419. A warp drive with more reasonable total energy, Chris van den Broek, Classical and Quantum Gravity. Volume 16, 3973-3979, 1999. 0420, on the warp drive spacetime, Pedro F. Gonzalez Diaz, Physical Review D, Volume 62, 44005, 44012, 2000. US 2006, 00739776L25. 0421, on the possibility of warp bubbles, Chris van den Broek, summary of talk delivered at STAIF 2000. 2000, 0422, reduce total energy requirements for a Modiif Dalcubia warp drive spacetime, F. Loop D. Weight, and E. Halowich Jr., 2001, 0423, warp drive with zero expansion, Jose Naterio, Classical and Quantum Gravity, Volume 19, 1157-1166. 2002, 0424, a causally connected superluminal warp drive spacetime, F. Loop R. Held D. Weight E. Halowich Jr., M. Stavno, M. Kuntzman and R. Sims 2002. 0425, weak energy condition violation and superluminal travel, Francisco Lobo and Paolo Crawford 2002. 0426, on the problems of hazardous matter and radiation at faster than light speeds in the warp drive. Spacetime, C. B. Hart, R. Held, P. K. Hoyland, S. Jenks, F. Loop D. Martins, J. Nyman, J. P. Pertira, P.A. Santos, M. A. Shaw, R. Sims, M. Stavno and T. 0, M. TH 2002. 0427, 2+1 Gravity, Chaos and Time Machines, Banks and I. And Branlin J. J. Math. Phys. 42-2001-3565. 0428, Time Travel in Einstein's Universe, The Physical Possibilities of Travel Through Time, Got J.R. Horton. Mifflin Company, Boston, 2001. 0429, Gravitational Memory of Natural Wormholes, Ankordoki LA Trobo ML Bucetic H Sizeman F. Mod Physlet A15, 6 429-438, 2000. 0430, a traversable singularity-free wormhole. The gravitational memory phenomenon got time machines. BTZ black hole formation, and Chobchuk scaling, Birmingham D, Sen S, Phys Rev left 84, 2000, 1074, 1077. It is shown that the GOT time machine provides a mechanism for black hole formation. 0431, negative energy, wormholes and warp drive, Ford LH, Roman, TA, Siam. 46-53, 2000 Jan, reply, 2000. May P. 12, 0432, warp drive spacetime, Gonzalez Diaz PF, Physrev D62, 044005, 2000. 0433, Misna Brain Cosmology, Gonzalez Diaz PF, Physlet B486, 158-164, 2000. 0434, Kinks, Energy Conditions and Closed Time-like Curves, Gonzalez Diaz PF, in J-Mod Phys D9, 5. 531-541, 2000, GRQC, 0007065. 0435, will we travel back, or forward, in time? God Jr., time, April 10, 2000 pp 68-70. 0436, charged universes of the Gödel type with closed time-like curves, Klipag P and Horsky J, class quant gray. 17, 13, 2547, 2555, 2000. 0437, the Orisoan Time Machine, Olam KD, Physrev D61 2000 124022. 0438. How much energy do closed time-like curves in 2+1 spacetimes need? Tiglio MH, Phys Rev D61 2000 08. 1503. April 6, 2006. 0439. Energy conditions and the cosmological consequences. Visser M and Barcelo CGRQC 00010999. 0440. Cylindrically symmetric spinning brand stick spacetimes with closed time-like curves. Anchordocky LA. Perez Bigliaffer SE, Trobo ML, Berman GS, Modfiz Letal 4, 1999, 1105-1112. 0441. From spinning to non-spinning cosmic string spacetime. De Laurent CVA de Paula RDM Svater NF. Class Quant Gray 16, 10, 3047, 3055, 1999. 0442. Bounds on negative energy densities in static spacetimes. Fuster CJ, Teo E, Phys Rev D 5910, 10. 4016, 1999. 0443. Decohering a charged scalar field in a time March-Ein wormhole background. Flagger MSN, in J-Thea. Phys 38, 82121, 2161, 1999. 0444. Rotating black holes in unified theories. Gibbons GW. Progress of Theoretical Physics Supplement. 136. 18 to 28, 1999. 0445. Supersymmetric rotating black holes and causality violation. Gibbons GW and Herdero CR, Class Quant. Gray 1611, 3619, 3652, 1999. 0446. Perdurance of multiply connected to sitter space. Gonzalez Diaz PF, Phys Rev D59, 1999, 123,513. 0447. Non-orientable spacetime tunneling. Gonzalez Diaz PF, Garay LJ, Phys Rev D59, 1999, 064026. 0448. Can the universe create itself? God Jr. and Lee XL, Phys Rev D58, 1998, 023501. Also, Astro PH, 9,712,344. 0449. Supersymmetric rotating black holes and causality violation. Holstess, Matchell HJ Class Quant Gray 16. 1999, 3095. 0450. Gödel type universes in string-inspired charged gravity. Canty P. Bayanakis CE. Phys Rev D60, 1999. 103,519. 0451. Quantum field theory and time machines. Krasny KOVS. Phys Rev D59, 4010, 1999. Jan the 14th of December, 1998. 0452. Time machines constructed from anti-de Sitter space. Lee LX. Phys Rev D59, 1999, 084016. 0453. Wormholes in string theory. Bollig DN. Class Quant Gray 16, 5/15/99, 1604, 1999. 0454. Time machines and the breakdown of Unitera T. Antonsen F and Borman K. in J-Thea Phys 37, 9. 2383, 2393, 1998. 0455. An exterior for the Gödel spacetime. Bonner WB, Santos N0, McCallum MAH Class. Quant. Gray. 15. 1998, 357, 366. 0456. All the World's a Time Machine. Chown M. New Scientist 157, 2124, 38 to 41, 1998 Ma. Short exposition of M. Hadley's idea that an elementary particle is a local street walk that it permits closed time-like curves. Hence general relativity could explain, the effects of QM. 0457, Quantum Time Machine, Gonzalez Diaz PF Phys Rev D58 12 4011, 1998. US 2006 00739760 Al. 0458, A Design for a Quantum Time Machine, Gray Aquan PH, 9804008. Misleading title, On QM Measurement Problem, Quantum, Seeing into Future. 0459, Time Machines with Non-Compactly Generated Cauchy Horizons and Handy Singularities, Krasnikov S. V. GRQC, 9,711,040, to appear in the proceedings of the 8th Marcel Grossman Conference. 0460, A Singularity-Free WEC Respecting Time Machine, Krasnikov SV, Class Quant Gray 151998-997-1003. 0461, Self-Consistent Vacuum for Misner Space and the Chronology Protection Conjecture, Lee LX and God Jr. Phys Rev Let 80, 2980, 1998. Misner Space Stable to Quantum Fluctuations, Against CPC. 0462, Decoherence Caused by Topology in a Time-March-Ein Spacetime, Mensky MB and Novikov ID, int. J. Mod. Phys. D51996127. 0463, Gödel metric as a squashed anti-de Sitter geometry, Raman M, Spindle PH Class Quant Gray 15, 1998. 3241, 3249. 0464, Testing Causality Violation on Spacetimes with Closed Time-like Curves, Rosenberg S, Phys Rev D. 57, 63365-3377, 1998. Pulitzer trademark used to investigate the scattering experiment, interesting results on agreement with the no-CTC case if there is enough TMs. 0465, a new non-Hausdorff spacetime model for resolution of the time travel paradoxes, Charlot MF Annals of Physics 263, 179 to 197, 1998. 0466, Particle Creation Near the Chronology Horizon, Sus HKOVSV, Phys Rev D58, 1998, 044006. 0467, Divergences in the Effective Action of a Causal Spacetimes, Cassidy MJ, Class Quant Gray 14P523. 1997, shows that a self-consistent quantum vacuum for Misner space exists, allowing time travel. 0468, the one-loop instability of Misner space, Cassidy MJ, Class Quant Gray 15, 8. 0469, superluminal subway the Krasnikov tube, Everett AE and Roman TA, Phys Rev D56, 4, 2100-2108. 1997, 0470, Time Machines and the Principle of Self-Consistency as a Consequence of the Principle of Stationary Action, E. The Cauchy problem for a self-interacting relativistic particle, Carlini-A and Novikov ID, in J. Mod Phys D5, 445 to 479, 1996 October. 0471, Warp Drive and Causality, Everett AE, Phys Rev D53, 12 pp 7365, 7368, 1996 Ringholes and Closed Time. Light Curves Gonzalez Diaz PF Phys Rev D54, 10, 6122, 6131, 1996. 0472, time machine as four-dimensional wormhole, guts AKGRQC, 9,612,064. 0473, got time machines in the anti-de Sitter space, Holstess Gen Rel Gray 28196387-403. 0474, the quantum stability of the time machine, Krasnikov SV, FizRev D541996-7322-7327. April 6, 2006 26. 0475, must time machine be unstable against vacuum fluctuations, Li LX class quant Gray 13-1996-2563. 2568. 0476, three-dimensional Billy. Odds with time machine, Mensky MB and Novikov ID, in J mod Phys D5 2. 179 to 192, 1996. 0477, decoherence caused by topology in a time March-Ein spacetime, Mensky MB and Novikov ID, in J. Mod Phys D5 1, 1 to 27, 1996. 0478, improved time machine model, So and Y and Ori A, FizRev D54, 84858, 4861. 0479, unitarity restoration in the presence of closed time-like curves, Anderson A, FizRev D51, 1995. 5707, 5715. 0480, problems in time machine construction due to wormhole evolution, Antonsen F and Borman K, in J. Theophys 34 1995 P 2061. 0481, time machines, the principle of self-consistency as a consequence of the principle of minimal action, Carlini. A. Frolov VP, Mensky MB, Novikov ID, and Soleng HH, in J mod Phys D41995557-580, Eratimibid. D51996999. 0482, nonlinearity in quantum theory and closed time-like curves, Cassidy MJ, FizRev D521995-5676. 5680. 0483, unitarity of quantum theory and closed time-like curves, Fuster CJ, Wells CG, FizRev D52. 1995-5773-5782. 0484, time machines without closed causal geodesics, LoRj, class quant Gray 12, 5, L37 L38, 1995 May. 0485, a remark on kinks and time machines, Yurtsever U, Gen Rel Gray 27, 691 to 693, 1995. 0486, the warp drive, hyper-fast travel within general relativity, Alcubierre M, class quantum Gray 11, L73. 1994. 0487, energy momentum restrictions on the creation of God time machines, Carol SM, Fahy, Gut AH and Olim KD, FizRev D50PP 6190, 6206, 1994. 0488, kinks and time machines, Chamberlain A, Gibbons GW and Steph AR, FizRev D50, 4, PPR 2353R2355. 1994. 0489, the breakdown of quantum mechanics in the Pre-ENCE of time machine, Goldworth DS, Perry MJ and Piran. T, Gen Rel Gray 25 PP7, 131994. 0490, quantum propagator for a non-relativistic particle in the vicinity of a time machine, Goldworth DS, Perry M. J, Piran T and Tomei KS, FizRev D49, 83951, 3957, 1994. O491, Time Machine, Self-Consistency in the Founder Tions of Quantum Mechanics, Ganella F. Found Phys. Led. 7, 2, 161 to 166, 1994. O492, Time Walk Through the Quantum Cosmic String, Gonzalez Diaz PFGRQC, 9,412,034. US 2006, 00739766L27. 0493, Unitarity and Causality in Generalized Quantum Mechanics for Noncronal Spacetimes, Hartle J.B., Phys. Rev D49, 12 pp 6543, 6555, 1994. 0494, 2 plus 1, dimensional spacetimes containing closed time-like curves, Hedrick MP, God Jr., Phys. Rev D50, 1994, 7244, 7259. 0495, Time Travel, Jaguar, Ukrainsky Physicheski Journal, 39, 1, 6-14, 1994. 0496, On the Classical Stability of a Time Machine, Krasnikov SV, Class Quant Gray 11, 11, 2755-2759, 1994. November, 0497, Isometrics Between God's Two-String Spacetime and Grant's Generalization of Misner Space, Lawrence D. Phys. Rev D50 pp 4957, 4965. 0498, Negative energy densities in extended sources generating closed time-like curves in general relativity. With and without torsion, Soleng HH, Phys. Rev D49 1994, 1124, 1125. 0499, Multiparticle Solutions in 2 plus 1 Gravity and Time Machines, Steph AR, in J Mod Phys. D3, 1, 277 to 280. 1994, 0500, Van Vleck Determinants Traversable Wormhole Spacetimes, BISA M. 0501, Algebraic Approach to Quantum Field Theory on Non-Globally Hyperbolic Spacetimes, Yurtseva U, Class. Quant Gray 11, 1994, 999. 0502, Cosmic Strings and Chronology Protection, Grant Jade at Phys. Rev D47, 2388, 1993. 0503, Complex Geometry, Quantum Tunneling, and Time Machines, Lee LX, Zhu JM and Lu L, Phys. Rev D48, 10. 4735, 4737, 1993. 0504, Quantum Field Theory in Spaces with Closed Time-like Curves, Bolware DG, Phys. Rev D46 1992, 4421. 4441. 0505, Global Structure of God's Two-String Spacetime, Cutler C, Phys. Rev D45p. 487 to 494, 1992, Corchi. Horizons for God's Machine, Two-String Spacetime. 0506, Cosmic Flashing, in 4 dimensions, Ford LH and Roman TA, Phys. Rev D46, 1328-1339, 1992. 0507, Unitarity of Interacting Fields in Curved Spacetime, Friedman. J.L. Parpastamasha, Phys. Rev D46 4442, 1992. 0508, Phi-law of unitarity for interacting fields on space-times with closed time-like curves, Friedman J.L. Puppers. Tamasha, and Simon J.Z., Phys. Rev D46, 4456, 4469, 1992. 0509, particle creation for time travel through a wormhole, Kim SW, PhysRev D46, 2428, 2434, 1992. 0510, time machine and self-consistent evolution in problems with self-interaction, Novikov ID, PhysRev D. 45p. 1989, 1992. 0511, structure of the singularity inside a realistic rotating black hole, PhysRev Let, 68, 2117, 2120, ORIA. 1992, 0512, simple quantum systems in spacetimes with closed time-like curves, Pulitzer HD, PhysRev D46, 4470, 4476. 1992, April 6, 2006. 0513, quantum mechanics near closed time-like lines, Deutsch D, PhysRev D44, 10, P3197, 3217, 1991. 0514, billiard balls in wormhole spacetime with closed time-like curves, classical theory, Echeverrier F. Klinkhammer G and Thorne KS, PhysRev D44, 4, p. 1077-1099, 1991. 0515, closed time-like curves produced by pairs of mobbing cosmic strings, exact solutions, got JR, PhysRev. Left 66, 1126, 1991. 0516, inner structure of a charged black hole, an exact mass inflation solution, ORIA, Rev Left 67, 789, 1991. 0517, on the outcome of Kerr-like collapse, Charlton N. and Clark CJS, classical and quantum gravity 7 no. 5 May 1990. 0518, Cauchy problem in spacetimes with closed time-like curves, Friedman J., Morris M.S., Novikov I.D. Echeverrier F. Klinkhammer G., Thorne K.S. and Yurtsever U., PhysRev D42, 61915, 1930, 1990, QM fixes the trademark classical billiard paradox, Polchinski's PRDX. CTCs may be not as nasty as people have assumed. The principle of self-consistency in time travel reviewed. 0519, traversable wormholes from surgically modified Schwarzschild spacetimes, BISSER M, NUCL Phys B 328 pp. 203 to 212. 0520, traversable wormholes, some simple examples, BISSER M, PhysRev D39, 3182, 3184, 1989. 0521, minimal acceleration requirements for time travel in Gödel spacetime, Malamenzi, Journal of Mathematique. Cal Physics 26, 1985, p. 774 to 777. 0522, time-like non-geodesic trajectories which violate causality, a rigorous derivation, de Felice F. Nuovo. Cemento 65 BPP 224 to 232, 1981. 0523, rotating cylinders and the possibility of global causality violation, Tipler FJ, PhysRev D9 pp 2203. 2206, 1974. 0524, global structure of the Kerr family of gravitational ifls, Carter B, PhysRev 174, p. 1559, 1968. 0525, complete analytic extension of the symmetry axis of Kerr's solution of Einstein's equations, Carter B, Phys. Rev 141, p. 1242, 1966. 0526, Acta Physica Polonica, Staruskiewicz A24, 1963, p. 734. 0527, an example of a new type of cosmological solute-ions of Einstein's field equations of gravitation, Gödel. K. Rev Mod Phys 21p. 447, 1949. 0528, gravitational field of a distribution of particles rotating about an axis of symmetry, Van Stockham W.J. Prokar-Sok Eden 57 pp 135 to 154, 1937. 0529, Appendix A, the synthetic creation of micro-singularities. Throughout this patent application, the creation of micro-singularities has been maintained. While at first glance this may seem to be a deficiency in the patent application, it is in fact an engineering problem that is in the process of being solved. In the International Journal of Theoretical Physics 41, 11, 2073-2090, November 2002 L. J. Garai published Black Holes in Bose-Einstein-Condon. US 2006, 007397 al. States. In this article, Garai showed that there exists both dynamically stable and unstable dilute gas Bose-Einstein condensates that, in the hydrodynamic limit, exhibit a behavior completely analogous to that of gravitational black holes. This discovery, coupled with creation of color glass condensate, CGC, an extreme form of nuclear matter in which a nucleus travels at near-light relativistic speed which flattens like a pancake in its direction of motion and spawns a large number of gluons, hold the key to high-energy singularity formation. I claim 1. A method for the generation of a pseudo 2+1 diamond cyanyl anti-de Sitter space comprising the steps of creating two Kerr-type positively charged rotating dilation singularities, including the steps of maintaining one of the singularities as our axis of rotation reference singularity, maintaining the other of the singularities as a target singularity, and subjecting the target singularity to a differential electron LFOW so as to simultaneously pass the differential electron flow above a photosphere of said target singularity in a direction of rotation thereof and contrary to the direction of rotation thereof, in order to release a directed flow of gravitons in a sinusoidal oscillation. April 6, 2006, 28. Simulating a rotational effect of the target singularity around the axis of rotation provided by the reference singularity. 2. A method of generating a force around a body, comprising the steps of employing sinusoidal oscillations of electrical bombardment on the surface of one Kerr-type reference singularity in close proximity to a second Kerr-type target singularity to take advantage of the Lenz-Thirring effect, wherein the electrical currents employed in the bombardment are passed simultaneously across the photosphere of said reference singularity in its direction of rotation and contrary to its direction of rotation to release a directed flow of gravity.